All right, welcome. Buckle up, folks, because today we're diving into something pretty fascinating. Graph applications.
Yeah, graph applications. It might sound a little dry at first,
It does, kind of, yeah.
but trust me, the stuff we're going to uncover today is going to change the way you see the world, how things really work.
Totally. Because we're talking about connections,
hmm
relationships.
Absolutely. And the material you pull together, it's just mind-blowing how this stuff rooted in good old-fashioned math is being used to understand everything from like how people act on social media
Yeah.
to the whole global economy.
Right. Like, who knew graph theory could be so powerful? I mean, we've got articles here about how it's being applied to, like, analyze social networks and markets, even, like, predict how diseases spread.
It's incredible, right?
Yeah, it's wild. So our mission today, to break all of this down, we're going to distill the essence of these ideas and show you how, just by looking at the relationships between things, could be people, companies, ideas, whatever, you can uncover hidden patterns and opportunities.
It really is about giving you a new way of seeing the world, like literally seeing the connections that are all around us but often hidden.
So before we get too far, let's clarify what we mean by graph application.
Sure. So at its core, you've got graph theory. It's a way to represent things, entities, they call them as points. These points are called vertices or nodes. And then you have the connections between those points. Those are edges or links.
Okay, think of it like, think of a map of friendships, like in a high school or something.
Perfect example.
Each student's a node, and if they're friends, boom, you draw a line and edge between them.
Precisely. And a graph application takes that idea and uses it to model, analyze, and understand complex stuff happening in the real world, like really intricate social and economic stuff.
So instead of just looking at each student individually, we're looking at how they all connect and interact as a group.
Exactly. We're shifting our focus from individual attributes to the entire network of relationships.
Which is super relevant these days, right?
Yeah.
I mean, think about all the data we have now, social media, financial markets, global supply chains. It's all interconnected.
Right. Like, you can't understand how the world works by just looking at isolated pieces anymore.
It's like trying to understand how a car engine works
hmm
by just looking at individual parts without seeing how they connect and interact.
Exactly. It's about seeing the whole system.
Okay, so we've got this basic idea of what a graph is. What about the key components of graph theory? Those keep popping up in our sources.
All right, so we've got nodes, which we've talked about. These are the individual players in our network.
Right, like a person in a social network or a company in a global supply chain,
Exactly. And then you've got edges, the connections between them.
representing all sorts of relationships, like friendships, business deals, links between websites.
Yep. And these edges aren't all the same. You've got binary edges, basically, just saying whether a connection exists or not.
So, like, are these two people friends? Yes or no?
Right. But then you've got valued edges, which go a step further. They tell you about the strength of the relationship.
Like how often two colleagues email each other instead of just, do they email at all?
Precisely. So we can see the difference between, just casual acquaintances versus those who are really collaborating closely.
Got it. So it's a lot more nuanced than just a simple connected or not connected.
Exactly. And then you've also got to consider if your graph is directed or undirected. A directed graph, the edges have a specific direction, so it's a one-way relationship.
Like following someone on Twitter. You see their posts, but they might not see yours.
Perfect.
Yeah.
While an undirected graph has connections going both ways, think of a business partnership where both sides benefit.
Makes sense.
Mm.
So a follow doesn't automatically equal a fallback, but a partnership implies a two-way street.
Mm.
Okay. What else?
Oh, we've got weighted graphs. Here's where we assign specific values to the edges.
Weights.
Exactly. This could represent, let's say, the frequency of communication or the amount of money transferred between two banks.
Or, if we're looking at airline routes, the weight of the edge between two cities could be the number of flights per day.
Precisely. And the key thing to remember is that choosing the right type of graph, directed or undirected, weighted or not, depends entirely on what you're trying to analyze.
Okay, so we've laid some serious groundwork here. Let's see how all of this is being used. Starting with the social sciences. I'm really curious about this.
Yeah, me too. The applications are incredible. In sociology, for example, graph theory is huge in social network analysis.
SNA.
Yep, S&A. Remember, people or groups are the nodes, and their social connections, friendships, family ties, professional networks. Those are the edges.
Right. And S&A gives us tools to measure influence, right?
Yeah.
Like who's the most connected, who's most influential.
Exactly. We use what are called centrality measures to pinpoint the key players in a network. You've got degree centrality, basically, how many direct connections a node has. A high degree often means someone's a real hub of activity.
Like the person who seems to know everyone at a party.
Exactly. Then there's between centrality. This measures how often a node is on the shortest path between two others. So they're like the connectors, bridging different parts of the network.
Oh, that makes sense. Like the person who introduces two people from completely different worlds
Mhm.
who end up collaborating on something amazing.
Exactly. Then you've got closeness centrality, how easily a node can reach all other nodes. High closeness often means quick access to information.
Like they hear about stuff first and they can spread the word fast.
Exactly. And then there's eigenvector centrality, which is a little more complex. It factors in the quality of your connections. Being connected to well-connected people boosts your own score.
So it's not just how many friends you have, but who those friends are and how influential they are.
Right. Okay, now another important concept is clustering coefficient, or transitivity. This looks at the likelihood that the friends of your friends are also your friends.
So like how tight-knit a group is,
Yeah.
whether everyone knows everyone else.
Right. Then we've got network density, the overall level of connectedness, and network diameter, the longest shortest path between any two nodes. It gives you an idea of how far information might have to travel within a network.
So a small diameter means that even people on completely opposite sides of the network could still be relatively closely linked.
Precisely. And then, oh, this is cool, there's community detection. Algorithms that can actually find those densely connected subgroups within a larger network.
So like automatically identifying different departments or teams within a company based on who communicates with whom the most.
Exactly. And the applications of all of this in sociology are vast. Understanding social support systems, how innovation spreads, social influence, the structure of groups. It's like revealing the hidden architecture of society.
Whoa. So what about psychology? How does graph theory apply there?
Well, similar to sociology, psychology uses graph theory to model social relationships, but it often focuses more on individual behavior and well-being, like how does the structure of someone's social network affect their stress levels, or how easily they adopt healthy habits.
So how our social connections impact our mental and physical health. That's interesting.
It is. And our sources also talked about how graph theory is being used to analyze brain connectivity.
Whoa, so it's not just external social networks, but the network inside our own minds too.
Right. They treat individual neurons or even different regions of the brain as nodes, and the connections between them as edges. It's giving researchers insights into how the brain functions, develops, and what might be going wrong in certain disorders.
That's amazing. Okay, now, economics.
Yeah.
I feel like this is a field that's always relied heavily on models. Where does graph theory fit in?
Oh, economics is all over this. One crucial area is understanding financial institutions. Graph theory helps model those complex relationships and analyze the potential for financial contagion. You know, how the collapse of one bank could ripple through the entire system. Traditional risk models often look at each institution in isolation, but graph applications can see the network of risk and how interconnectedness can make things more vulnerable.
Makes you realize how fragile things can be, right? Like
Right.
one weak link can bring down the whole chain.
Right. It's also helpful for studying patterns of ownership and control within industries, how economic ideas spread, and market dynamics in general. There's this thing called agent-based modeling that often uses network structures to simulate how individual economic actors behave.
So you can model like an entire market as a network of buyers and sellers making decisions based on their connections and the information they're getting.
Exactly. And then political science, relationships and power dynamics are like the core of politics.
Totally. So how is graph theory used there?
Well, there's policy network analysis, which looks at all the players involved in making public policy.
Government agencies, lobbying groups, think tanks, all that.
Yep, and you can map those connections to see who's influencing whom and how decisions are being made. In international relations, graph theory helps analyze things like global organizations like the UN, alliances between countries, trade relationships, even patterns of conflict and cooperation. There's this concept of network power, looking at a country's influence based on its position in the network. Like, do they have access to key players? Can they bridge different groups?
So it's like looking at the global political landscape as this giant web of connections with different players holding varying degrees of power.
Exactly. Oh, and graph analysis is also being used to study political polarization, how social networks contribute to echo chambers, and those increasingly divided opinions we see.
Which is a huge issue these days, online and offline. Okay, it's clear that graph theory is giving us some powerful ways to understand social and political stuff. Now, what about business? Our sources highlight some really cool ways these social science principles are being applied in the business world.
Oh, yeah. And it's not just about understanding things better. It's about using these insights for a competitive edge. Like in marketing, for example, businesses are using S&A to map their customer relationships and find the influencers.
Those are the people who have a lot of connections and whose opinions really matter, right?
Exactly. By understanding those network structures, companies can tailor their advertising to be way more effective. Instead of just blasting a message out to everyone, they can focus on reaching those key influencers who can then spread the word through their networks.
Much more targeted.
Right. Another big area is fraud detection and anti-money laundering.
Oh, yeah, that makes sense.
Businesses, especially in finance and e-commerce, are using graph databases to map out all the relationships between accounts, transactions, devices, all that. Think about it. Traditional fraud detection often just looks at individual transactions in isolation. But graph applications can reveal whole networks of fraudulent activity. They can connect the dots and find patterns that would be completely invisible otherwise.
So it's not just looking at a single suspicious transaction, it's seeing if it's part of a larger web of potentially dodgy stuff.
Exactly. You can use link analysis to uncover those hidden connections, anomaly detection to spot unusual behavior, and community detection to find groups of accounts that are all acting suspiciously. And graph databases are much better at handling this kind of complex, interconnected data than those traditional relational databases.
Right, right. Okay, now what about recommendation systems? Those things are everywhere online.
Oh yeah, and graph theory is a major force behind them. They work by suggesting products or content to you based not only on your past behavior, but also on what other similar users like and the relationships between different items. There's collaborative filtering, which uses a network of users and items to find people with similar tastes, and content-based filtering, which suggests things that share characteristics with what you've already liked. And often, platforms use hybrid systems that combine both approaches. They use algorithms like PageRank, that's what made Google search so good, and different random walk algorithms to analyze the network and figure out what to recommend.
So when a website suggests you might also like this, it's probably using graph theory to do it.
Most likely, yeah. And then supply chain optimization and risk management. This is a big one. Businesses can model their whole supply chain as a network with suppliers, manufacturers, distributors, and retailers as nodes, and the flow of goods and information as edges.
So you could visualize that whole flow and identify any weak points.
Right. They can use this to find bottlenecks, optimize routes, manage inventory, and, really importantly, assess the impact of disruptions. Like, if a key supplier suddenly has a problem, the network model can show you exactly which other parts of the supply chain are going to be affected.
Super useful, especially with all the supply chain issues we've seen recently. Because we've seen all these amazing applications. But how are companies actually building businesses around this stuff?
Right. So how are they actually making money? We're seeing a few main models emerge. A big one is software as a service platforms, or SaaS. These platforms provide graph analytics tools and infrastructure, often cloud-based. So companies like Neo4j, they've got OraDB, Amazon has Neptune, and there's TigerGraph Cloud and Nebula Graph. These companies let other businesses build and analyze their own graph data, and they usually make money through subscriptions with the different tiers based on how much data you're using, how many users you have, what features you need, all that.
So you're basically renting the tools and infrastructure to work with graph data.
Exactly. Another common model is data analytics and insight services. Specialized companies or consulting firms use their graph expertise to analyze data for clients and give them actionable insights. This could be through reports, dashboards, strategic recommendations. They'll usually charge per project or have some kind of retainer agreement. Like, imagine a market research company using S&A to analyze social media data and give brands insights into their perception and competition.
So they're like the graph experts who can apply this stuff to specific business problems.
Exactly. And then you've got consulting services that specifically help businesses figure out how to use graph theory for things like fraud detection, recommendation engines, supply chain stuff. These services typically charge by the hour or have a fixed fee for a project.
So if you're a business and you know graph theory can help you, but you don't know where to start, you can hire these guys.
Exactly. And finally, there are market research and intelligence platforms. They collect and analyze tons of public network data, often from social media and other online sources, to give businesses insights into market trends and competition. They usually make money through subscriptions to their data and tools, by selling data licenses, or by doing custom reports for clients.
So they're basically mining all that public data for valuable nuggets of information. Now, beyond just providing these services, how are businesses actually making money from these insights? What are their monetization strategies?
Okay, well, as we said, subscription models are huge for SaaS platforms and anyone offering access to network data. Then there are project-based fees for data analysis and consulting, where the price depends on the project's complexity, how long it takes, the expertise involved, all that. Companies that develop unique graph algorithms or software tools can also make money by licensing that technology to others.
So if you've come up with a really clever way to analyze network data for a specific purpose, you can license that out.
Exactly. For recommendation systems, we often see revenue sharing or affiliate models. Companies get a cut of any sales that result from their recommendations, or they charge a premium to place certain items higher up in the recommendations. And lastly, there's data monetization, where companies analyze all that network data and then sell the aggregated, anonymized insights to other businesses.
So they're selling those patterns and trends they find without compromising individual user privacy.
Uh,
Okay, so we've got the theory, we've got the business models. What about real-world examples of this stuff in action?
Oh, there are some great success stories. Let's start with fraud detection. PayPal has been using custom graph solutions for years to analyze all the relationships between accounts and transactions in real time. And JP Morgan Chase, they've even publicly praised TigerGraph in their Hall of Innovation for helping them dramatically reduce false positives and speed up fraud investigations. Lending Club uses Neo4j as a core part of their fraud detection system. It really highlights how powerful this interconnected data analysis can be for catching sophisticated fraud rings that would slip past traditional methods.
So these major financial institutions are really seeing the benefits of looking at the network of relationships to identify fraud. What about recommendation engines?
Well, the specifics of how these companies build their algorithms are usually top secret, but just look at how much revenue Amazon makes from their recommendation system. It's a pretty clear sign they're using network analysis to understand what customers want and how products are connected. Netflix has said that a huge chunk of their views come directly from their recommendation engine, which also points to a graph-based approach. eBay and Walmart both use Neo4j for their recommendation systems, trying to give their customers the most relevant suggestions possible. And these systems are great at uncovering those unexpected connections that can lead to more serendipitous and ultimately more valuable recommendations.
Yeah, it's hard to imagine those platforms without their recommendations now. They're so integral to the experience. What about influencer marketing, which we talked about earlier? Any good examples there?
It's tricky because companies don't always spell out exactly how they're using SNA in their campaigns. But the whole idea of finding and engaging with highly influential people in social networks, that's at the heart of so many successful campaigns. Think about the buzz around the Barbie movie, Invisalign's TikTok strategy, Apple's hashtag shot on a phone thing. They all likely used insights into network dynamics, whether they were doing formal SNA or just had a good understanding of how social media works. And then there's Spotify Wrapped, which is brilliant because it uses that user connection data in a network-like way to get people sharing and talking about it.
Right, so even if they're not explicitly saying, hey, we used social network analysis, the strategies are often aligned with those core principles of finding and leveraging those influential nodes in the network.
Exactly.
Okay, now let's talk about challenges. Implementing these graph applications can't always be easy, right?
Yeah, definitely not. One big one is data heterogeneity. Getting data from all these different sources and integrating it into a unified graph model can be a real headache. Then there's scalability. As the volume of data keeps exploding, you need the infrastructure to handle all that processing and storage. And of course, data quality and accuracy are critical. You need to make sure the data makes sense and that you're not drawing misleading conclusions.
Classic garbage in, garbage out problem.
Exactly. And you also need the right resources, both in terms of technology and expertise. You need people who really know about graph modeling, database management, and analytics. Plus, getting data ready for a graph database is different than traditional databases. It's about defining entities and relationships. And then there's the learning curve for end users who might need to use specialized query languages and tools.
So it's not just a technical thing, it's also about having the right people and skills in place.
Absolutely. And we can't forget that adopting any new technology often faces internal resistance within companies.
People get comfortable with how things are done, and change can be hard.
Right. But despite all these challenges, the opportunities are huge, right?
Totally. Based on our sources, the potential benefits are pretty amazing. Better customer understanding, better strategic decisions, a competitive edge by uncovering hidden patterns, more effective marketing, better fraud detection, more accurate and relevant recommendations. Plus, optimization of supply chains and other business processes.
It's a long list, but it all boils down to this. If
Yeah.
you implement graph applications effectively, you can fundamentally change how your business operates and understands the world.
Pretty powerful stuff.
Yeah.
So, final question. Where do our sources say all of this is headed? What's the future of graph applications?
The future looks bright. The demand for graph databases and applications is expected to skyrocket. We're going to see more integration with AI and machine learning, which will make analytics more powerful and lead to better predictions. Real-time processing is becoming increasingly important, especially for time-sensitive things like fraud detection and personalized recommendations. And graph databases are getting more powerful, with better analytics capabilities that allow for deeper exploration and more complex queries.
It's all about uncovering those deeper connections, right?
Exactly. Plus, there are continuous improvements in things like query optimization and indexing, which make analysis faster and more efficient. We're seeing more intuitive data visualization tools specifically designed for graph data, which makes it easier for people who aren't tech experts to understand these complex networks. And the move toward cloud-based graph database services will likely continue, offering better scalability, easier management, and potentially lower costs.
So basically, we're moving toward a future where understanding these complex webs of connections is going to be even more important, and graph applications will be the key to unlocking those insights.
That's the big takeaway.
So as you go about your day-to-day, think about all the networks you're a part of, your friends, your colleagues, the flow of information you encounter. Even just thinking about these things in a simple graph-like way can give you a fresh perspective. And it makes you wonder, right? With all the data we have now and the incredible advancements in graph technology, how will our understanding of influence, relationships, and complex systems evolve in the years to come? What new possibilities will we unlock?
It's a pretty exciting time.
It is. And if any of the stuff we talked about today, whether it's social network analysis, fraud detection, those companies building these tools, if any of it sparked your interest, I encourage you to dig deeper. There's a whole world of interconnected knowledge out there waiting to be explored.
There's always more to learn.
Always. Well, thanks for joining us for this deep dive into the world of graph applications. We'll see you next time for another exploration of the interconnected world around us.